Hello, this is Carl Freund with Cambrian-AI Research. I have a couple of interesting gentlemen from IBM with me today. We'd like to talk about quantum safe. So this isn't about safe quantum computing. This is about making sure that existing data and infrastructure is safe once quantum computing has sufficient capacity and capability to actually crack the codes that are used in everything from our phones to our supercomputers and mainframes today. So with us today, I've got Ray Harishankar, who's an IBM Fellow for Quantum Safe, and John Buscelli, who's the Offering Manager for IBM Research for Quantum Safe. Welcome, gentlemen.
Thank you, Carl. Happy to be here.
Great. Well, you guys kind of did almost a clean sweep so far on this. I mean, out of the 4 algorithms that the National Institute of Standards has selected out of, gosh, was it 40 or so, or 70? I can't remember. Anyway, out of all those, they selected 4, and 3 of those were contributed by IBM Research. So first of all, congratulations. That's quite an accomplishment.
Thank you.
Why don't we start, just kind of describe for our audience why quantum safe is important now when quantum computing that could crack codes may still be many years or even a decade away. So why don't we start with that? John, you want to take a crack at that?
Sure. Well, you make a very good point. Obviously, the threat of quantum computing is on the horizon in terms of the actual power and capabilities of quantum computing. But from our vantage point, the threat is here today. And it really revolves around 2 or 3 fundamental points. Perhaps most important is the fact that information exfiltrated today in the not too distant future, given the long time horizons in which data needs to be protected and preserved, or the long tails of applications that are often kept in production for many, many years, and therefore have cryptography that could be cracked by a quantum computer in the future, are what put information and systems at risk. And that's really the basis of the quantum safe argument today. Yeah,
so avoiding the steal now, crack later kind of threat that's out there today. So where are you guys in making data quantum safe? I noticed that the new Z16 has at least one of the algorithms, I think the signature algorithm included. What's kind of the roadmap for getting us to a quantum safe world?
Ray, would you like to go first?
You want to go first on that, Ray?
Sure, why not? So Carl, you're absolutely right. IBM Z16 is the industry's first quantum safe platform or system, and it actually uses the crystals Kyber and crystals dilithium as the underpinnings of its key, encapsulation and digital signature capabilities. But interestingly enough, that was not really the first ones. As we submitted these algorithms, took a bet that these would really be in the final set. So we actually began to incorporate them into our tapes, 2 years ago. And then, we also have this as part of our IBM Cloud. And then now we have the recent announcement around Z16. So that's on the hardware side of things. And then on how we are going to help our clients with their, to your earlier point about how do we safeguard the data, the infrastructure, and the applications, we are now beginning to work with our clients on how we can identify where they should focus their efforts in and how they can, become quantum safe iteratively over the next several years. So that's where we are focused.
Interesting. So do you have a process you go through to help them understand where their exposures might be? What does that look? Is it like an IGS engagement?
Yes, it is. Initially it starts off as a services type of engagement, because it's primarily what we recommend is that, again, it's not like, let me now kick off a project or an initiative that will make everything quantum safe. That's too big to really execute from an initiative standpoint. So we recommend iteratively working through this, but you first have to figure out where the vulnerabilities are that you have, prioritize them so you can go about it in an appropriate manner, to the point that John made earlier about, hey, there is data that is sensitive, and there are some time value of that data that we need to take into consideration. We will in fact find that there are certain systems that we want to address right away, and there are systems that we can do later. That's one aspect of it. The other is also that when you begin working on these, we will learn more and more about the client's environment, the best way we can do it. Maybe we can discover patterns of remediation. And we also don't look at just remediation, like let's just take the old crypto and replace it with the new. We also want to look at how we can improve the overall agility of the crypto architecture, if you will, and make it more suitable for future changes that may come, right? The industry calls it crypto agility. So it's not just remediate the old and replace it with the new. We look at it as remediation where required and transformation where appropriate.
Oh,
and I may just add to that,
please.
The ability to bring kind of a comprehensive view, not only around governance where current and future state can be defined, we're also looking to ensure that we're educating people, making them aware of the issues that we spoke about earlier, but also readying management for this transition so they can understand the implications, while we're also giving pragmatic access to algorithms for experimentation, sandbox testing, and things of that nature as well. So it's sort of both practical and operational at the same time.
Interesting. So John, what sort of expectations do you set with these clients in terms of the time frame in which they have to prepare and remediate and transform their infrastructure to be quantum safe?
That's a very good question, and I'll preface it by saying it's actually difficult to answer it with its degree of precision. But in the spirit of the question, what we're counseling our customers on is this is a journey. This is a multi-year effort. Unlike a Y2K kind of scenario, there's not a particular moment in time, and it really depends on prioritization, data transformation efforts, digital transformation efforts, overall readiness, scale, scope, complexity. And so first and foremost, we have to understand that, where then a pragmatic roadmap can be given, where there will be more insight and clarity as to what the transformation process will look like. But to say that this is 3 to 5 years or 5 to 7 years in terms of an industry-wide and corporate entity-wide journey is not out of the question. That's pragmatic.
Is that primarily just limited by the capacity of the machines, have enough qubits to be able to factor these prime numbers?
It's more driven by the fact that organizations are complex, and the requirements to transform an organization and transform cryptography that is widely used in a very diverse way in the modern corporation simply takes time and effort. So from a pragmatic point of view, I would say it would take a period of time, right? We're obviously trying to automate it and make it as efficient and as expeditious as possible, but this will take some time. It's a journey, as we like to say.
One point to add there, Carl, is that the enterprise cryptography implementations and the associated crypto architecture are complex, and they've organically grown over time, right? A lot of acquisitions, new packages, and some are old, some are new, and that is complex. And what we're also finding is, for example, the simple hash algorithm SHA-2 was upgraded with SHA-3, and we had one client comment to us that it took them 7 years to replace SHA-2 with SHA-3. So there are other data points like that lead us to indicate that the time frame that we're looking at is 5 to 7 years, as John was talking about.
So people have 5 to 7 years to understand where their vulnerabilities are, understand how they can be remedied, but also how they can transform their infrastructure to be more, as you put it, agile in handling cryptography as it evolves and changes over time.
Right. Just to be very precise, we want them to understand it sooner than 5 to 7 years. But then what we see is the transition plan or transformation plan typically takes 5 to 7 years, given all the considerations.
Interesting.
Yep.
Interesting.
But I also add to that, with that comes prioritization. So
Mm,
higher value, greater areas of concern would obviously be transformed sooner.
Right.
So the protection landscape of the organization would be achieved sooner with secondary and tertiary projects out on the horizon.
interesting. Yeah, obviously we want to protect, security critical information ahead of, our favorite song list, right?
Well said. Everybody
Yeah.
wants to protect the crown jewels, as they
Right.
say.
Yeah.
Exactly. Interesting. Well, when I first heard about quantum safe, I got it backwards. I thought we were talking about safe quantum computing, not being safe from quantum computing.
Mhm.
And the thought of steal now, crack later, suddenly then light bulbs went off. It's like, oh, okay, this is something people need to pay attention to now. So I'm glad we had this conversation. I can do my part to help people become aware of the need to understand and explore and remedy their IT infrastructure to be safe from potential attacks from bad actors using quantum resources. Yep. Is there anything else you want to mention before we wrap it up here?
The only point I would like to call out is, people draw a parallel from Y2K to YQK. And while there is fairness to it in some areas, it's also not an appropriate parallel in some areas. And I already talked about the fact that we need to not just look at remedy, the old crypto and replace it with new crypto, but look for transformation, right? And one more plug I'll put in is for this notion of observability, right? Observability typically refers to understanding the behavior of a system based on instrumented data, and then take action based on it, obviously. Mm-hmm. We believe that expanding that notion to include crypto-related data and associated decisioning is important, and it is an opportunity, because if you're just replacing it, is sort of you're staying at the same level of playing field. How can we improve that so that decisioning on crypto-related challenges can be real-time, dynamic, AI-driven, automated, right? Decision-based, data-based, or information-based, or insight-based. That's, I think, the timing is right in that we are touching every crypto system and talking about crypto agility. If we can improve this to include that, I think that will be a significant improvement in the overall crypto landscape and architecture.
Interesting. That's fascinating.
Mm-hmm.
Well, first of all, thank you guys for the work you're doing to help keep us safe from potential threats across our infrastructure around the world. IBM Research clearly has taken the lead here, and your engineering and scientific work around this area is going to have a massive impact in keeping the world safe from bad actors with massive computing power. So thank you both very much for your time today. I look forward to continuing to watch this space, and have you back soon for another update on this as we progress.
Thank you, Carl. Enjoyed talking with you, and appreciate the opportunity.
Thank you very much. Thanks, John. Thanks, Ray. We'll talk to you soon. Take care. Bye-bye.